The moon has held our imaginations for millennia. It has a historical and cultural significance that really seems to resonate with people. Anyone in the world can look up at the night sky, see the moon, and understand how amazing it is that a spacecraft built by humans is roaming around the surface. Lunar exploration began in earnest in the 1950s, with the United States and the USSR developing and launching robotic spacecraft. In 1959, the USSR's Luna 1 was the first spacecraft to fly by the moon. In 1966, Luna 9 achieved the first soft landing, and in 1969, the US's Apollo 11 achieved the first human landing. In the decades since, many nations have contributed to lunar orbiters and landers. Till today, the interest in the moon still is driven by similar goals as in the first space race that occurred more than a half-century ago, demonstrating technological capabilities and inspiring young people and the general public. But the difference is that the new moon race is not the private playground of the two powers. We now have many participants in the Moon Lander Club. For instance, early this year, a Japanese spacecraft has soft landed on the moon, making Japan only the fifth nation in history to achieve the feat. Called Smart Lander for Investigating Moon, or SLIM, the car-sized robotic lander. Initially launched in September 2023, JAXA's Smart Lander for Investigating Moon, or SLIM, a car-sized robotic lander, took nearly 4 months to slowly reach the moon's vicinity and finally entered lunar orbit on December 25, 2023. It then spent 3 weeks gradually lowering its orbit down to just 15 kilometers in altitude before beginning its landing attempt on January 19th. It is the second Japanese spacecraft to attempt a landing on the moon. The first, the Hakuto R mission from the Japanese firm space, crashed into the lunar surface in April 2023. Only the US, the former Soviet Union, China, and, most recently, India, had successfully landed on the moon before now. The mission's primary goal was to test a new method for extremely precise automatic lunar landings, earning SLIM the nickname Moon Sniper at JAXA. The mission had a targeted site that is just 100 meters wide, in contrast with the kilometers-wide landing zones of previous missions, such as the crewed Apollo landings. The demonstration of that pinpoint landing is the symbol of the project, says Yui Nakama of the European Space Policy Institute. SLIM sought to reach this precision thanks to cross-checking its position against detailed mapping of the moon's surface by Japan's Kaguya orbiter and NASA's Lunar Reconnaissance Orbiter. Using onboard navigation cameras and autonomous image processing, the spacecraft continuously scanned the surface and identified craters and boulders to adjust its descent in hopes of a safe pinpoint landing. Having lowered its orbit to an altitude of about 5 kilometers, the spacecraft then began a vertical descent, free-falling to an altitude of 500 meters before firing its thrusters to hover and scan the surface below for obstacles. It next dropped to 50 meters and performed another hover and scan until, tilting on its side, it fell to the surface from a height of 3 meters onto the slope of Scioli crater. The touchdown should have been gentle because of the moon's weaker gravity, as well as cushioning from 5 small spherical shock absorbers. The whole landing procedure lasted 20 minutes, referred to as 20 minutes of terror by SLIM sub-project manager Kenichi Kushiki in a blog post last year, and was followed by an agonizing extended wait as mission controllers struggled to understand what had befallen the spacecraft on the lunar surface. Demonstrating such a precise landing could be a valuable tool for targeting regions at the moon's poles that receive permanent sunlight to prolong the lifetime of landers, or for visiting scientifically rich locales. According to Osinski, who is part of the geology team selected by NASA for upcoming human landings that the agency has planned for the water-rich lunar South Pole, it opens the door for going to more scientifically interesting places. We want to go to big boulders or rocks exposed in crater walls. You've got to be sure you're not going to hit any of those on landing. However, things didn't go entirely to plan that day. It's been a wild ride for Slim, ever since it made a precise touchdown on the rim of Scioli crater on January 19th. It ended up upside down. Images of Slim taken by the baseball-sized robot rover Lunar Exploration Vehicle 2, or SORA-Q, which was released by the spacecraft just before landing, revealed that in achieving this precise landing, Slim came down rotated at 90 degrees, effectively landing on the tip of its nose. Japan Times reported that Slim project manager Shinichiro Sakai explained that JAXA scientists believe that Slim's strangely orientated landing came about as a result of one of its two main engines stopping during the 30 seconds or so of touchdown and at an altitude of around 50 meters over the moon. This engine failure caused Slim to drift 55 meters away from its chosen landing site. Without the glitch, Slim could have landed as close as 3 to 4 feet from the selected region of the moon. The SORA-Q image shows the shift in position meant that Slim set down on the sloped ridge of a lunar crater. This incline caused the spacecraft to roll westwards onto its nose. But Japan Times added that Sakai said that the loss of the engine was the result of an undisclosed external factor, adding a camera had captured an engine nozzle lying on the lunar surface. This statement really confuses everyone. What exactly is external factor? We just don't know. And so people's imaginations go wild and plots appear in droves. Many scientists believe that the moon may be more than just a natural satellite. In fact, some go so far as to claim that the moon is an alien base. This conspiracy theory arose due to the existence of unusual structures on the moon. The surface of the moon is scarred with tens of thousands of impact craters of various sizes. Scientists suggest this is due to the fact that there has never been an atmosphere on the moon to protect it from bombardment by space debris. There are no natural erosive forces like wind or flowing water to affect its surface, and there is little geologic activity to conceal damage done throughout the moon's history. When you study the distribution of craters, you find the surface is totally saturated. That is, there are craters with increases in the number of craters right down to the smallest scale of size. One of the things that's really interesting about lunar craters is that even though some of them are very large and some of them are very small, they all seem to have the same depth. This uniformity in depth is unusual on a planetary body, where there should be a variation in depth. So why are the moon's craters so uniform? Well, it's really not explainable in terms of conventional or established geophysics. And among the most prominent anomalies is the Tycho crater, renowned for its central peak that some researchers and conspiracy theorists suggest exhibits characteristics of artificial construction rather than natural geological processes. This hypothesis posits that such features could be remnants of ancient alien installations, potentially serving as observatories or bases for monitoring Earth. The Tycho crater's geometric symmetry and the unusual formation of its central peak continue to fuel debates among scientists and enthusiasts alike, challenging conventional interpretations of lunar geology and inviting speculation about the involvement of intelligent extraterrestrial beings. Another compelling lunar anomaly is the tower, a structure that gained attention after being captured in NASA photographs. Rising prominently from the lunar surface, the tower stands out as a starkly anomalous feature, leading to speculation and theories that it could be a remnant of alien technology. Some proponents of the alien hypothesis suggest that the tower might serve as a navigational beacon or a marker left behind by ancient extraterrestrial visitors, indicating points of interest on the moon, or possibly even guiding interstellar travelers. The tower's mysterious appearance and its potential implications continue to stir curiosity and controversy, prompting calls for further investigation to unravel its true nature and significance. In addition to specific anomalies like the Tycho crater and the tower, broader lunar features such as the Mare Orientale Basin also present puzzling characteristics that have fueled speculation about extraterrestrial involvement. Mare Orientale is known for its concentric rings and complex topography, which some theorists propose could be indicative of a massive spacecraft or a deliberately constructed lunar habitat rather than a natural impact basin. This hypothesis challenges traditional interpretations of lunar formations and invites exploration into the possibility of advanced extraterrestrial civilizations capable of engineering such colossal structures for their own purposes. The enigmatic nature of Mare Orientale continues to inspire debate and intrigue within scientific and enthusiast communities alike, underscoring the complexity of understanding the Moon's geological history and the potential implications for the search for extraterrestrial life. While these hypotheses about unusual lunar structures and their connection to alien factors are met with skepticism by many mainstream scientists, proponents argue that anomalies on the Moon warrant serious consideration and investigation. They advocate for a more open-minded approach to exploring the possibility of alien artifacts or structures, which could offer profound insights into the history of lunar evolution and potentially the existence of intelligent extraterrestrial life beyond Earth. The study of unusual lunar structures not only challenges our current understanding of celestial bodies, but also raises fundamental questions about humanity's place in the universe and the potential for encountering other intelligent civilizations. Scientists expect a giant leap toward understanding the Moon in the near future when lunar exploration is undergoing a renaissance. Dozens of missions, organized by multiple space agencies and increasingly by commercial companies, are set to visit the Moon by the end of this decade. The NASA-led Artemis 3 mission will place the first human boots on the surface of the Moon since Apollo 17's Gene Cernan and Harrison Schmitt left the lunar surface in December 1972. The goal of the Artemis program is to establish a permanent human presence on Earth's natural satellite and an economy based around the Moon. Artemis 3 is scheduled for no sooner than September 2026. However, further delays are likely, and there are many technical challenges yet to overcome. Some might wonder whether it is going to happen at all. I am convinced it will because, unlike the Apollo program, which would be unaffordable in today's climate, the current lunar endeavor will pay off in financial and exploration terms. Extracting water ice from craters at the lunar South Pole could facilitate journeys from the Moon to other destinations, such as Mars, bringing down the cost of space exploration. This is why the booming space industry seems fixed on the Moon as a destination right now. Countries simply cannot afford to miss this boat. The space sector can boost whole economies. In the 1960s, the space race was driven mostly by Cold War-era political and military muscle flexing. There is still some of that in addition to the rush for resources. After 1972, human spaceflight became limited to low Earth orbit as the U.S. switched from the Apollo spacecraft to the Space Shuttle. But in the 2000s, the U.S. announced that it would be building new space vehicles to ferry astronauts to deep space destinations, such as the Moon. That same decade, the U.S. also made a strategic decision to employ the ingenuity and cost-effectiveness of young companies such as SpaceX and Blue Origin. Owned by some of the world's richest entrepreneurs, Elon Musk and Jeff Bezos respectively, they are marked on the outside by passion and risk-taking, but are based on solid business models. SpaceX's enormous Starship vehicle was contracted by NASA to ferry Artemis astronauts between the proposed Gateway station orbiting the Moon and the lunar surface. Starships were destroyed on each of their first 3 test flights. However, the pace at which problems are rectified is remarkable, and, a year on, the 4th integrated test flight of Starship saw both the upper stage and Super Heavy rocket make soft landings. This reaffirms SpaceX's competence in breaking frontiers of innovation and to provide reliable, affordable services. It is renowned for its upright return landings of launch vehicles, essential for human missions to and from the surfaces of the Moon and Mars. However, Jeff Bezos's Blue Origin, has been contracted to land the Artemis 5 crew on the moon later this decade, with its own lander. NASA clearly does not want to place all its eggs in one basket. Recent attempts to land on the moon have highlighted the fine line between success and failure. A fuel leak cut short a mission by private company Astrobotic in January 2024. It was part of a NASA program aimed at kickstarting private transport services to the moon. A thruster malfunction caused Russia's Luna 25 to crash during an attempt at a first landing near the lunar south in August 2023. This occurred as Russia appears to be losing its front-row seat in scientific and commercial space activity. A few days later, India's Chandrayaan-3 lander touched down successfully, making them the fourth nation to softly land on the moon. Japan, as told, followed suit in January 2024 when their SLIM mission landed. Shortly afterwards, Houston-based Intuitive Machines later became the first private company to make a soft, if wonky, landing on the moon. Its Odysseus lander vindicated NASA's belief in private enterprise engagement as the future for sustained lunar exploitation. Long-established aerospace companies such as Boeing are heavily involved in Artemis, but it seems just a matter of time until relatively new kids on the block can go it alone, without the burden of a space agency's bureaucracy and the whims of congressional approval. There are two other relevant players in the moon race. The China National Space Administration, or CNSA's human space program, has been catching up fast. Operating its own space station, Tiangong, it has replaced Russia as the main competitor to NASA. China aims to place boots on the lunar soil by 2030 and build a base called the International Lunar Research Station. They will partner with Russia and various countries with little or no previous space experience, such as South Africa and Egypt. CNSA's lunar program has been flawless, with the uncrewed Chang'e 6 spacecraft landing softly on June 1, 2024. Its objective is to return samples of soil and rock from the far side of the moon. The other player is the U.S. Department of Defense. Its Defense Advanced Research Projects Agency and Novel Orbital Moon Manufacturing Materials and Mass-Efficient Design Program is aimed at developing the capability to build things in space. Its lunar architecture study, Luna 10, to be carried out over 10 years, aims to develop infrastructure for the lunar economy, such as transportation, wireless power generation, and a communications grid. But with this intense effort come ethical questions and a need for enforceable laws and regulations. Is it right to mine the moon? Who owns the land there? We also need to think about whether the water at the lunar South Pole should be consumed until there is nothing left. Dating to 1967, the UN Outer Space Treaty stipulates peaceful activity in space and on other celestial bodies. But these are non-binding principles which say little about economic activity. Neither do the U.S. Artemis Accords, which have been signed by 42 countries as of May 2024. These do not include China and Russia. It is almost certain that by the mid-2030s, there will be 2 lunar bases in operation. Private and state-owned companies will harness its resources, manufacture products, generate energy, and offer stays for tourists. All this comes with technological innovation that may provide solutions on Earth. The race to the moon offers opportunities for peaceful international cooperation and shared economic prosperity. It will also inspire a new generation of engineers and entrepreneurs. For better or for worse, it will be a milestone in the evolution of our species and bring Mars within reach as our next destination. Indeed, Mars has called to us since ancient times. To humans across the eons, the red-tinted speck glinting in the night sky has garnered special attention, with myths and legends wound around its possible ties to Earth. As we observed Mars with telescopes, this fondness graduated into a scientific fascination. Within only about the last half-century, as science has continued to advance, we gained the ability to land scientific instruments on the red planet. Beginning with the Viking probes in 1976, and continuing through the Perseverance rover and its flying companion, the Ingenuity helicopter drone, this robotic exploration has allowed humans to discover complex secrets of Mars. But this is far from the end of our ambitions. Indeed, humans have planned crewed missions to Mars since at least as far back as the 1950s. Scientists and CEOs alike have crafted intricate ideas to establish a presence on the red planet, ranging from small-scale research outposts to major settlements. Elon Musk's plans to put 1 million people on Mars stand as a particularly bold example. However, even with all the money and influence being poured into the goal of putting boot prints in the Martian regolith, there remain considerable doubts that we will ever actually get there. Between economic and ecological problems mounting here on Earth and the major challenges facing even the most basic mission to send humans to Mars, the impetus to spend the money necessary to fund such an initiative has ebbed with the political tides, perhaps more so than any other space mission. Whether it be the dangers of deep space radiation or the possibility of failure in the equipment that keeps them alive, the astronauts who travel to Mars will have to overcome dangers before, during, and after their trip to the red planet. But as the thousands of applications submitted to the now defunct Mars One enterprise clearly show, plenty of people would gladly sign up. What is it about Mars that draws people with such gravitas? It is a barren, desolate place, after all. That much has been clear from the earliest flybys in the 1960s. The days in which dreamers like Percival Lowell and Edgar Rice Burroughs imagined Mars as a flawed but still inviting destination are long gone, replaced by an era in which futurists argue over whether it makes sense to terraform Mars, thereby altering the red planet into something more closely resembling Earth. And, essentially, no one realistically addresses whether such a thing is actually possible. But the fascination remains, and the call of Mars is still as loud as it was to the futurists of the past. There seems to be something of a destiny in this call that makes it all but inevitable that humans will one day step down onto the surface of Mars, much as we once first stepped onto the surface of the Moon. This history itself is instructive. In the earliest days of the space race, many people thought it inevitable that humans would one day set foot on the lunar surface, even if it took decades as opposed to the scant few years promised by visionaries like John F. Kennedy. But the illusion of inevitability is not proof of its existence, in fact, as many failed predictions through history have shown. Even the moon landings were subject to faulty predictions. The New York Times 1920 declaration that rockets could not fly through space due to the lack of air comes readily to mind. But on July 21, 1969, 2 men from Earth stepped onto the surface of the Moon, proving all but the most determined doubters wrong. Will their spiritual successors at NASA and other space agencies one day follow suit on Mars? The first person to step on Mars likely walks among us now, and their moment in history may be coming soon. Let's look at things as they are now. Earlier in 2023, NASA and DARPA announced a partnership to design nuclear rockets, which some attest could be the first step toward a Mars mission. Elsewhere, analog habitats funded by organizations like the Mars Society simulate missions to Mars to prepare potential travelers for the journey. And futurists like Robert Zubrin and Elon Musk draw up plans to send people to Mars by as soon as the late 2020s, with Musk claiming he can establish a colony of 1 million people by 2100. But does any of this mean that Mars pulls us toward its shores any more intensely now than at the height of space-age optimism when visions of grand cities on Mars seemed near to fulfillment? The basic fact is that when humans set our minds to do something, we see it done much more often than not. The South Pole, the summit of Everest, and, of course, the Sea of Tranquility are all evidence of that. So while the exact details of a future Mars mission are unclear, where it will take place, who will be the first to step out of the spacecraft, what flag they will bear, if any, and perhaps, most importantly, when it will happen, The possibility that it does happen is much larger than the chance we will never set foot on Mars. It may take decades, but even if it takes another century, it seems likely that someone will one day become the Neil Armstrong on the Red Planet. When that one small step takes place is anyone's guess, but the high probability that it will happen seems undeniable. And according to scientists, using the Moon as a stepping stone to Mars represents a strategic approach that harnesses lunar resources and capabilities to facilitate humanity's exploration of the Red Planet. This concept leverages the Moon's proximity to Earth and its potential as a testing ground for technologies, systems, and human endurance in deep space missions. Establishing a sustained presence on the Moon, such as through a lunar base or outpost, would enable scientists and engineers to refine technologies crucial for Mars missions, including life support systems, habitats, and resource utilization techniques. One key advantage of using the Moon as a stepping stone is its relative proximity to Earth compared to Mars. A crewed mission can get to or from the Moon in just 3 days, whereas a mission straight from Earth to Mars, or vice versa, would take at least 7 months, with a round-trip mission estimated to last approximately 500 days. That helps to reduce logistical challenges and costs associated with long-duration space missions. Lunar missions could serve as a testing ground for new spacecraft designs, propulsion systems, and autonomous operations that are essential for Mars travel. Furthermore, the Moon offers valuable resources that could be utilized to support both lunar and Mars missions. For instance, water ice deposits in permanently shadowed regions of the Moon's poles could be extracted and converted into drinking water, breathable oxygen, and hydrogen fuel through electrolysis. These resources could be used to sustain astronauts during lunar missions and potentially be transported to Mars as part of interplanetary exploration efforts. Establishing a lunar base could also serve as a training ground for astronauts preparing for Mars missions. The Moon's lower gravity and harsh radiation environment provide an environment similar to deep space, allowing astronauts to acclimate and test equipment in conditions more representative of Mars than Earth's environment. This preparation would be invaluable for ensuring the safety and success of crewed missions to Mars, where astronauts would face long-duration stays in microgravity and exposure to higher levels of radiation. Moreover, the experience gained from operating a lunar base could inform the development of international collaboration and governance frameworks necessary for conducting complex interplanetary missions. Establishing partnerships between space agencies and private companies on lunar exploration could lay the groundwork for future cooperation on Mars missions, fostering a global effort to explore and colonize other celestial bodies. In summary, using the Moon as a stepping stone to Mars represents a strategic approach that leverages lunar resources, capabilities, and proximity to Earth to advance humanity's exploration of the Red Planet. Establishing a sustained presence on the Moon through a lunar base or outpost would enable the testing of technologies, systems, and human endurance essential for Mars missions, while also providing valuable training opportunities for astronauts and fostering international collaboration. By building upon lunar exploration efforts, humanity can pave the way for future missions to Mars and beyond, expanding our understanding of the universe and our place within it. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.